All right. Good morning, good afternoon, or good evening on behalf of VP Instruments. Depending on where you are in the world, we hope that everybody who joins us is feeling okay, is in good condition, is healthy, in spite of the corona crisis that is ongoing globally at the moment. This VP Instruments webinar will guide you through an optimization of a compressed air system. The title of the webinar is a green compressed air system even. And we do this with a co-hosting this time. So it's not only VP Instruments that is talking to you, it's also one of our respected business partners, Mr. Gunnar Krukenberg from Germany, who will introduce himself shortly. Gunnar has been a business partner for quite a few years now. First of all, during his time at the family company, Krukenberg Compressed Air in Germany. And currently he is working at AF Compressors in Belgium. So he is an experienced guy and he wants to tell you more about a very practical case actually, which is the feedback that we got from the audience during previous webinars. Please, VP Instruments, make the case as practical as possible. Show us some results of an optimized compressed air system. So a situation before and after. Well, we listened to you, so we found Gunnar willing to share a case with you, for which we thank him. And he will tell you in the next, let's say, 40 to 45 minutes what he experienced. And after the session, there is, of course, an opportunity to ask questions through the public chat box. I will manage that one myself. Gunnar can read it too. And if he misses out on any questions, I will share that with him in the presenter chat. So feel free to ask questions after the webinar. All right, Gunnar, if you're ready to go, you are in Germany at the moment.
Yes, thank you very much for the invitation.
All right.
Hello to everybody, and I hope you can understand me. The task, what we were facing at the customer were to create a new compressed air system and also to have a technology change, because it was a food company, quite big food company, and they had an oil lubricated system with intensive filtration. But due to risk management decisions, they wanted to have an oil-free compressed air generation. With the risk of worsening of the efficiency. They knew this in advance. And we had some technical challenge during this process, because it was not so easy to establish a solution, which I want to show you, because I will present you the complete process from the first contact to the final solution. So the classical approach when a customer comes to you and asks for a new air compressed or oil-free air compressor system would be that you would offer like dry oil-free screw compressors, or even maybe water-injected screw compressors, and some air treatments, and then it's normally a battle of price, who's getting this project. The customer in the beginning made very clear that they are interested in a TCO, so total cost of ownership consideration, and they were facing for the existing system a lot of troubleshooting, unplanned repairs and unplanned maintenance or actions from the maintenance teams, and they wanted to solve this because they do not have anymore the capacities. So they gave us freedom we established during the process a kind of freedom in consulting, and they opened up the project for us because we brought in an alternative. The first thing when we looked at the production of the customer, what came up to us was that the biggest saving potential at this client was not in the compressed air system. This would be on the long run, but on the short run, the demand side of the production. was offering a huge potential of optimization. And this is was in the past published with many other like researchers and campaigns, but I'm still surprised that we are still facing many clients who have 20, 30, or even 40% of leakage potential in their compressor system. And this is not just inappropriate use. This is the production. These are the leaks and the official demand due to a higher pressure band. And we had, in this case, all of these aspects. And we found out that round about 1/3 of the whole system, and more than 1/3 of the whole system in peaks, because leakages are changing quite quickly, were responsible for this avoidable production demand of compressed air. So, and I think many people are familiar with this cake slide where you show that roundabout, don't put it on a single number, but roundabout 80% of the life cycle costs are energy related. The investment is only 11, and 9% are the running service and maintenance costs for a lifetime for TCO. Look at technology or a system. But when you slice up the cake a bit different and put in this leakage potential inside, you have still a very big piece of the cake, which is indicating the relation to the customer. And this is a really common issue in the industry, that what we are facing. Not just in food companies, all kinds of industries facing this kind of problems, because and the main reason for this is that the simple workers or the responsible people, not the management, not the energy manager, but the simple workers in front of the machine, are not aware about this problem. And we decided that because we saw this huge potential, we wanted to go a complete different approach. So we first pushed our client that we told him we will reduce the compressed air demand before the optimization, and the new compressor system will be optimized on the new demand side, and not first establish a new compressed air generation system and then look at the demand side. If you put the interest, or if you're creating additional value in your offers, you have to really focus on the benefits of the customer, and the biggest benefits the customer will find in leakage reduction. So here you can see some examples of leakages, and it took us a lot of work to visualize the problems. We were documenting individual leakages. We were, and the second last picture in this slide is showing you, or the photos showing you individual leakage measurement of one leakage in a cylinder, where we could demonstrate that we have more than 145 liters leaking out of one single case. So, and we could relate this to the individual energy cost. And I learned it in the past from other high-tech companies, like, for example, Airbus. Airbus is displaying the cost of a product to each single worker. Each worker who's, for example, handling a turbine blade knows how expensive this piece is. It could be a few thousand euros, and then you have a totally different awareness, or totally different handling about the product or the situation. And most customers are not aware how expensive leakages are. And when you receive the presentation, you can download it, and we will share it. There is an embedded video for the first picture. In the moment, it's not working, but you can see really part of the product. It's a brown product the food company is producing, is blown out of this valve, and you really can see the leakage there, which is not often the case. And we measured this. And this is my most favorite example of a leakage. And this was hanging pure view in a big production hall of the customer for 1 year. So you see the black marks behind the hose, which is leading to the hose reel. And each black dot is a single leakage. So we had, if you have time, you can count the individual leakages in one single hose. And this was so eminent, but nobody took care about this. This cost more than 1,700 euros, this single leakage. And we could demonstrate and prove it because we had several times in the beginning. The customer did not believe us, and we were hanging a leakage mark there and was informing the company. And it took a long while till they fixed this. So it's very important to create a kind of awareness in these optimization systems. And our way. What I want to introduce to you is to create a green compressor system. If you have to put the customer in the center of interest and benefit, and if you do this, you have to start at the back with your consultation and with your solutions, what you provide for the client, not just in the beginning. What is our main target? Yes, we want to optimize the compressed air room. And but this is not the biggest helper for the client in the beginning, and it will be the wrong solution in the future when you optimize the demand side. And without visualization, the cost of a single leakage, the awareness of the worker is not given. And also important aspect is how you manage leakage optimization. We were not, there are many devices on the market. Most of them are quite good. And what is very important is that you should document the leakages kind of digital way in a database, and also manage and document the repair, because leakage surveillance or leakage monitoring saves nothing. Leakage repair only saves or creates savings for the customer. So you should have a tool which can follow up the repair process and documenting the success in this. And we were not measuring individual leakages in volume, because this will take too much time and it's just a rough estimation. You could use ultrasonic tools to measure the flow out of an individual leakage, but these measurements are plus minus 20% accuracy. And we were only focusing on the complete leakage range, which was much more accurate for us with different kind of measurements. We wanted to document the leakage. We wanted to be quite quick, and we are capable of looking over 5,000 to 6,000 square meters per day per technicians in an optimization process, so which is much more easier for the client. And in addition to this money value, the savings, you create more improvements. You can, for example, improve the working process. And here in this case, we could really good show the customer how leakage optimization can have a huge impact on the production side. This customer had a hydraulic press for their product, but the opening and the closing process for this hydraulic press was realized with pneumatic cylinders, 16 cylinders in a row. The first one is filled, and then the second one is filled because they were in line, and each one after each other. So, and in between of these, the process was really hot and very loud. So workers were could not stand next to it normally. And only with ultrasound, we were capable of documenting that there are a lot of leakages inside the single cylinders. And when they started this kind of pressing process, they had a 40-second cycle to produce their product. But nowadays, they are facing a 100-second cycle. With the repair of the leakages and the indicating of the problem, they could optimize the process back to a 40-second cycle, which was enabling the client to produce around about 1,400 euros per day more product value output, which is, and this production line was running 300 60 days per year, which is a huge saving. So, and this was opening for us many doors. Of course, they realized with this single case, we maybe should listen. But you have to prove it. Another positive impact on the equipment of the operators of the operation is that you reduce, for example, the repair rates, because a leakage is short before a malfunction. Benefits for employees and working conditions. Noise reduction will go along with reduction of leakages. And some areas we could reduce the noise level below the level where you needed earplugs for safety reasons. And of course, the leakage can be quite loud, noisy effect. And also the reduction in material and use of materials. So these are the additional impacts, or which you also should talk about or present to your client. What we made different at this case was also that I told in the beginning the classical approach would be to offer a screw compressor, but our client told us they are looking at the TCO costs for a long time and they wanted a sustainable solution. So we decided during the process to change our mind and go from a screw compressor to we saw that we would not have any success with the screw compressors. We go to oil-free double-acting piston compressor. And the biggest advantage of this technology is that it is much more energy efficient, much more sustainable, because compared to oil-free screw compressors, two-stage, it's lasting 4 times longer. You can regulate these pistons in the same way like a VSD-driven screw compressor. They're 100% oil-free, but they provide a solution which is reliable for decades. And they have much lower repair or maintenance costs, because the maintenance intervals are every 8,000 to 10,000 running hours, depending on the conditions at the client. So, but how can you establish or how can you prove what you promise? Because we were promising something totally out of the norm, a complete new technology, even it's old-fashioned technology constantly renewed, but it is not in the general awareness of the decision makers. So you have to establish flow sensors. And normally, if you go to a client, you will not face ideal or perfect situations that you can measure, centralize at the compressed air station, see the complete air demand. Of course, the pipelines are not created to consider flow measurements. They were created 10, 15 years or 20 years before. Nobody thought about measurements, and the lengths are not making it possible to establish a flow measurement, or you will have pipelines not monitored. So we started here with individual production lines and production rooms, and single compressors. So we were using wet air flow measurements, where you cannot use thermal mass measurements because they will destroy it or maybe damaged. So we were using here differential pressure measurement probes to measure the efficiency of the old existing compressors, and also thermal mass measurements probes for production lines and individual departments, which is normally quite easy to establish a connection, or you can organize a shutdown, or you will find a date for a shutdown to implement your measurement devices. And in the last end, we were facing the efficient monitoring of the centralized systems. But at this customer here, we had the problem. We had 3 old air compressor stations divided through over the whole facility. And our task was to create a new centralized room for the compressed air supply side. And we had also find the good location for it. that the pipeline and the supply could be diversified in the production without big losses. And a very important point I want to indicate it is you have to be aware of measurement failures. In the beginning, the client provided us with measurement data. They tried it by themselves. Energy measurements, amp meters were installed wrong. We were facing, for example, a 45 kilowatt oil lubricated compressor, which was only consuming around about 45 kilowatt, so 10 kilowatt less than expected. But normally the real energy consumption should be above 55 kilowatt for such a machine. What was the reason? The amp meter was 40 meters away from the compressor and had an average of 50 minutes inside of the measurement. So you could not see the startup peaks and the complete consumption. So you really have to check the data if you're getting data from the client, but also your own installations. Pipeline lengths are not like in this picture here, perfect designed for you. Inlet and outlet flow, dimensions of the pipelines, the air quality are a real important topic. And any kind of flow measurement is not a fire and forget solution. You are the experts, or you should listen to the experts, and VPs were providing a lot of help, also questions, to install these installations. And this is what we used in this process. So if we are now coming to numbers, saving data, the output data of the compressors normally are collected from the nameplates of the compressors, which are not correct. In reality, or displayed on the nameplates, we have 480 kilowatt, but the real measured value of the energy consumption is the clamping, or the complete energy consumption of the compressor plus air treatment. And in reality, it was 537.6 kilowatt. So the expected kilowatt cubic meter ratio, which is important KPI to compare systems, was totally different to the real measured KPI. And so it's very important to check the difference between assumption and reality. And you have to prove it inside of such a solution, which is often a lot of work, can take a lot of time, but this can also set you apart from competition. Coming back to the leakage potentials we found, we found around about 16 cubic meters, and this were only related to 50% of the complete production. We are in the moment fixing these leakages, and afterwards we will focus on the other 50%. So in a complete system with around about 70 cubic meters, we are facing 30 to maybe, but if we are on the nice side for the client, maybe 25 cubic meters complete, or cubic meters per minute only for the leakages. And if you are not fixing this problem, and you, with a surveillance system, with permanent measurement, you can bring down this rate to below 5% of the peak consumption. This is an acceptable value from my side and what we provide for clients, but not 30, 20, or 40% of the production. So coming to the compressor system, obstacles and resistance you will face. Of course, the fear of making a wrong decision is imminent in a consultation process. It's always quite easy to swim downstream, but bucking the trend is important. And your tools are dew point measurements, amp meters, kilowatt measurements, and I really suggest not just using amp meters, and they are good for the beginning, but later on going for the complete kilowatt measurement, it's important. Different kind of flow sensors to show the client what are the real figures, the difference between assumption and reality. And then you can even suggest complete new technologies or solutions for the client. And This is the most important, to put the customer in the center of interest and benefit. The consultation is becoming more important than the final product. And the customer is willing to pay for this part, the consultation, because it provides a value. And a very important aspect in the beginning, which I learned from other industries, is the customer does not know what he needs. And this is not offending the client or the end customer. You have to tell him what is possible in such a solution or in such a complete system. Of course, you are the knowledge holders, you want to be the knowledge holders, and you want to consult the client. And you have an idea in the beginning, a vision. And the client is only interested in the real savings in the end. He wants, and our task was less stress for the maintenance, a sustainable solution, an oil-free system, and lower energy costs. But in the beginning, there were nobody was talking about leakages. Everybody was talking about screw compressors. Nobody was talking that we changed from refrigerated dryers for the most of the production and just some decentralized desiccant dryers, and we changed the complete system to a complete desiccant dryer system with minus 40 degrees dew point, because they were facing quality problems in the production. So in the end, we realized the solution with 3 times 110 kilowatt, 8 bar, with according ISO 1217, 20 cubic meters output, oil-free compressed air. 2 new big air receivers, 6,000 liters. Air receivers can never be too big. They're always way too small. So, and then 2 desiccant dryers for redundant work and with steam regeneration. Of course, the customer had a lot of steam available. So it's a quite efficient and energy-friendly version of regeneration. Complete redundant air treatment, filters everything in parallel, nothing to be or failure-proof in flow. And on top, a superior compressed air management system to visualize and to collect all of your KPIs. We have wet measurement for the individual compressors, individual kilowatt measurements for the each compressor, and a complete kilowatt measurement for the complete installation, for the complete air compressor room, plus a dry energy measurement for the complete installation. And this is leading us to, and this is real measured figures, to a cubic meter kilowatt ratio of 5.83 compressed air for the complete compressed air, full power, with minus 40 degrees. 100% oil-free, which is a very good value. Nobody was expecting this in the beginning. And the customer is really happy about this because he can also prove these values and can follow up and can monitor the system. And he's going for decentralized measurements for the consumption, for the production, to keep track on upcoming new leakages, because leakage optimization is a permanent battlefield. And there's no correct reason in monitoring or taking action there. It should be monitored with decentralized multiple flow meters for production lines, production rooms, halls, or individual lines. So, and they can tell you for a very limited amount or for a nice saving when to take action in system, and very quickly, because in the past, they only could see the complete consumption. All compressors are running, we have to run around, and one guy was sent around to find one single hose which is more maybe broken and constantly blowing out air. And they had cases where 30 millimeter hose was blowing freely in the production because the production was really loud, and nobody was looking at it. And this can be easily detected and monitored with decentralized flow measurements. So coming to the improvements, a reliable compressed air source, 100% oil-free, without risk, complete visualization, and with KPIs. So you have to create in consultation with your client which KPIs are eminent or important. This can be according to the rules like 50,001 or EMAS or 14,000. Any kind of energy system will ask for certain KPIs, especially the 50,001, which was in this case a big driver for us, because this will force the client to make decisions under a long time perspective and not just facing the investment. No, the energy factor is one of the most decision-making factors in 50,001 cases or clients who are certified with the system. And you can also create in the end automatic reports. So you create an easy view, easy insight into the energy flows, which is a nice way to describe it from VP. And this brings me to the end of my presentation. I hope you enjoyed it and have some questions.
Okay, great, Gunnar. Thank you very much. That was a very interesting case. I will give the audience a minute to formulate their questions in the public chat room. You all get copies of the slides, indeed. You all get copies of the presentation afterwards. You will get a link by email. I have a question for you, Gunnar, basically. What do you think was your biggest challenge during this whole project? What kind of challenge was the one that you thought, oh, am I going to make it? Am I going to take away this obstacle?
The turnover from facing the leakages first in the optimization process and to show really results in it, because this took us 2 years.
Mm-hmm.
First, they hired a competitor. He could not provide good results. Then we making surveillance. They were not believing the results. We made a lot of measurements afterwards to show that it's possible. Then we got a tiny production site or space of the production to optimize. And then we could scale it up till now to 50% of the production. And also to introduce, but this was based on measurements and guaranteed energy figures, was quite short. The change of technology for the compressors. But as soon as we could bring the topic back, only listen to the KPIs and providing security in the technology, there was no decision left. They said, well, we want to go this way because this is more durable, more sustainable, more energy friendly, more ecological friendly, and we want to have it.
Yeah. So would you conclude that it was the, let's say, the product or the technical factor, or was it more like the human factor?
The human factor. The human factor, the consultation, the complete package. Because in the beginning, they would not believed us if we would have popped up out of the clouds or jumping out of the bushes, we say in Germany, hey, we have a more energy efficient piston, but everybody else is offering screw compressors. Yeah. They would not have listened. And by the way, we don't want to talk at the beginning about your new compressor system, even if you invite me to this. Let's talk about your production. There are, we call it the failures. You cannot transfer this message to the client in the beginning is because it's not a failure. It's a lack of awareness. Yeah. And the technology in the past was not there, because it's now with easy flow sensors, with easy monitoring systems, possible to indicate this. Many years before, it was not so easy.
You're right. Okay. In the meantime, Gunnar, I do have 2 questions from the audience for you. How do you quantify the potential of improvement? Is it knowledge of the industry?
We are facing this leakage potential through all kind of industries. And I'm quite surprised that it's still averagely way above or above 20%. I'm always going to clients to say there's a 20% source of optimization or potential. But I often find clients who have facing more. In the compressed air rooms, there's easily, with the change of technology, and when they want to make the step from oil lubricated or facing the competition dry two-stage screw compressors with piston compressors, you have an optimization potential of 15%. But this potential is also not common knowledge. It's still a big advantage in the consultation because piston compressors were a long time old-fashioned, and this source of technology is optimized since many years, but it's just getting a revival. Because nowadays you can get piston compressors which can be regulated like a VSD-driven screw compressor, but with a much more durable pneumatic solution inside. So you are compatible.
Okay. Another question from the audience. Do you have constant monitoring equipment currently at this application or at this client?
Yeah, definitely. We installed the permanent centralized cubic meter measurement for the compressor room, plus the kilowatt measurements. We have the individual measurement for the compressors, because we have to prove that we promised a constant energy efficiency of the compressors, and competitors or competing technologies like screw compressors will face after 10, 20, 40,000 running hours a decrease of efficiency. And we guaranteed at this client there will be no efficiency changes for the lifetime. And we're talking about a lifetime of 30 to 40 years. As long as they stick to standard maintenance intervals, but no big repairs, nothing, no change of errand. And we also established, and we have in the moment 2 decentralized production flow meters, and they will go up to 7. Planned for this year, maybe more in the future, depending on the impact. And this is an ongoing process.
Okay, all right. Could you also share some insight on the accuracy of the measurements that you took?
Yeah.
How accurate were the measurements?
Accuracy is a huge topic, and which I wanted to explain in the presentation. The biggest failure rate is wrong installations. So even if you're getting, especially with probes can face a lot of failures in the installation. I really like inline measurements, which are quite easy to be established or integrated in systems, and then they are more secure in accurate measurements. If you can have a shutdown, because you have to bring it into the pipeline and you have to cut the pipeline. If it's not possible, you really have to take care how you install the flow measurement, and you have to double check the estimated or the values which are presented with the reality. And you also have to control from time to time your sensors. Flow sensors are not a fire and forget solution.
Yeah, okay, you mentioned that in the presentation, yes. So do you actually have remote access to this site still, or does the customer do its own monitoring? Or can
the customer does its own monitoring. We will get historical data. In the beginning, we get it from a day later. Normally, the customer doesn't want to have a permanent access, because we get a really big inside view of the production. The compressed air is always a huge indicator of the output of a facility, which are sensitive data. In the beginning of the process, we normally get almost a live access or a very closed access. But when the system is established, normally customers faced a learning curve, they kick us out. And they come back when questions popping up.
Yeah. Okay. So would it be an idea to create that in the future also for other projects, like you can always access remotely, and you can even provide an additional service to the customer, like analysis of reports or something else? Yeah,
especially in the beginning of the consulting would be heaven. It will save a lot of time if it would be a cloud connection to the sensors you establish, which was for us not possible because it was not ready solution, and we have to install the sensor. Because it was a standalone sensor, we have to manually read out the data, creating curves, which created a lot of work. And we had also with VFP a lot of discussions and gave them some to-dos. We hope that there will be soon a much more easier solution, because it will save a lot of time. And there is also room for constant business models to provide consultation. You can have private clouds, you can have accessible clouds, so the customer can invite you to look at it. Of course, there are constant questions, and an easy access from your factory or from home is helpful, definitely.
Yeah, all right. So will you actually be using this case to get, let's say, an entry into a new customer project? Are you able to show a new potential customer what your working operation is, your way of working?
Yeah. I use this as to present also the way how I'm working and how, because we are standing behind this green concept. And for me, I'm here in this process facing a special situation, because I stepped out of the family company and was hired from AF, and they offered a quite green compressed air solution. And they are also behind this green concept, because each compressor is individually produced. We are not pre-producing and squeezing them into the market. So for us, it will be not a negative factor to first reduce the demand side and then offer a solution. But this is a beginning process.
Yeah. All right. Okay, Gunnar, I would like to thank you on behalf of VP Instruments, and I guess also on behalf of the audience, for sharing your story with us. You have indicated that you will be available even after this webinar to answer questions for people who have questions.
Yeah.
So that would be, ideal, I think. Like I told you, everyone is getting a copy of this presentation after the webinar. And yes, I would like to thank you all for joining. Enjoy the rest of your day. Have a good night or good evening. And stay tuned for the next webinar. Please follow us on our social media. We will announce the webinar most likely 1 or 2 weeks before, so you can easily subscribe and get more involved on the latest compressed air measurements or system updates. So thanks again, and until next time.
Thank you very much for your attention, and thank you for inviting me.
Okay, you're welcome. Bye-bye.
Bye-bye.